Further to question C, talking about how the root powers go slower to zero than the higher powers do. So here I've drawn in green the square root of x, in red is y equals x, and in blue is y equals x squared. And if I zoom out, clearly as x gets bigger, if we talk about endpoint behavior, the x squared is going to get bigger much faster than the linear function or the square root function. Okay, that's definitely true as we go to infinity. However, the behavior of these functions are different between 0 and 1. So if we focus in on between 0 and 1, we can see that this root function gets smaller slower. Okay, as we go to 0, it doesn't get as the value doesn't get as small as quick as the other functions. Whereas the squared, it will go to 0 much more quickly. So in the particular problem that we are doing, the square root is going to stay big as the x goes to 0. And if you zoom right in, and the closer we get to 0, the bigger the difference between the square root and the x is. Okay? And again, this only happens between 0 and 1. So this is a behavior of the root functions and the polynomial functions between 0 and 1. And we can see further that as we increase the power, okay, it's going to go to 0 quicker for power 6, and it's going to go to 0 slower for root 6. Okay, so we can see how they differentiate themselves even more the greater the powers are.